Hello, hello. Welcome everyone. Total developers back again with another overview video. And today we are discussing the origins and a little bit of review of the ternary search algorithm. So to begin this, we will be dividing into the origins and workings of the ternary search algorithm. And to start, let's understand what ternary search is, right? It's a divide and conquer search algorithm used to find the maximum or minimum in a unimodal function. So unlike binary search, which splits the interval into two parts, ternary search divides it into three, recursively narrowing down the search space. All right, so with that being said, let's go into a little bit of a historical background. So the concept of search algorithms dates back to the early days of computer science. Initially, binary search was the go-to method for its efficiency in reducing search space. However, ternary search was introduced to optimize specific problems. This evolution allowed for a more refined approach in dividing the search space, particularly useful in optimization scenarios. So next is how ternary search works, right? So the ternary search works by splitting the array into three parts as previously described. Then we calculate two midpoints, mid1 and mid2. These can be stored in variables. And we then compare the target value with these midpoints to determine which segments to focus on. This process repeats recursively until the target is found or the interval is empty. So this also relies on the initial array that we are given before this ternary search performs to be sorted. All right, so we then can compare it to a binary search, right? So ternary search and binary search both use that divide and conquer principle, but with slightly different approaches, right? So binary search splits the array into two parts and has a time complexity of O of log n, or big O of log n. And in contrast, ternary search splits the array into three parts with time complexity of big O log 3n. Although ternary search involves more comparisons, it can be beneficial in specific scenarios. Understanding these differences helps us choose the right algorithm for the task at hand. So some applications. So ternary search is particularly useful in optimization problems where the function is unimodal. It finds application in various fields such as investments, decision-making, models, research allocation and operations research, and certain game theory problems. These real-world use cases demonstrate how ternary search can provide efficient solutions to specific problems. So next, let's talk about the advantages and disadvantages. The main advantage of ternary search is its straightforward approach to dividing the search space. It's particularly effective in optimization scenarios and can simplify problem solving. However, there are some disadvantages. It often involves more comparisons than a traditional binary search, and that leads to higher computational overhead. Thus, while it excels in certain applications, it may not be the best choice for larger data sets. So, to summarize here, we've explored the origins, implementation, and applications of ternary search. We compared it with binary search. We've highlighted the strengths and weaknesses of each. Understanding these differences is crucial for selecting the right algorithm for specific problems. The ternary search splits the interval into three parts and recursively searches. making it useful in optimization and very specific applications. So I hope you enjoy the video, and in our next implementation with Rust, we will do a dive and write this code out. So stay tuned for that. I'll see you in the next one. Till then.